Okay, you're getting a preview of a very rough prototype that I'd like to talk to you about today. So I think this is, you should consider this a little bit of an informal kickoff to the later hack session, because I'm going to show you some really rough ideas, hopefully get you thinking about things you might work on yourself this afternoon. Just to give you a little background about myself, I graduated from MIT in electrical engineering and computer science. I'm here as a postdoc, and I've been trying to branch out from the work that I've done on large code bases. There are collections of code submitted by students in massive classrooms, or hundreds of thousands of repositories that are open and available on GitHub that have emergent structure that we can leverage when writing our own code. And for me, the white whale is text. I teamed up with several students from the EECS department and two professors, Marty Hurst, of whom has a lot of work in text, and I told them about how frustrated I was when I first tried to work on text as a PhD student. Okay, I had a social scientist. I took his class on Middle Eastern politics and policy. He's from Egypt. And he said, oh my gosh, you're a computer scientist. I'm going to give you millions of tweets from the Egyptian Revolution, and you tell me how people's political expression has changed over time. And I was like, great. It's like, I can do this, right? You know, it's the mind in hand MIT philosophy, just hit the wall. And I failed. But I did come away with this one reflection, which is that this data set, which was, there are many data sets that include texts that are released iteratively over time, reflecting some sort of change in the underlying truth. And they have different time resolutions, right? So you had this, if you looked at month by month, say, most popular terms, that kind of thing, you get this drumbeat of daily life, right? I can't remember the specific, it was a funny data set. These were tweets that were geolocated. People had turned on their location, and so as a random collection of folks, there would be one-off protests, like maybe potentially a very important clash, okay, on some side street near Tahrir. There were also TV show finales, right? People were really excited who was going to win. There were ongoing encampments that we were aware of because social scientists had actually studied this, the Arab Spring in depth. And amidst all of this, at an unclear level of frequency or time resolution, you had what you were actually interested in, which was this evolving expression about the transition of governments that were happening during these years. So I, coming from actually an electrical engineering background as an undergrad, really enjoying signal processing, I said, aha, multi-resolution analysis, where we separate different frequency bands of information. That's wavelets, right? If you're not familiar with wavelets, it is a really nice, okay, by the way, you know how like neural networks can supposedly solve all our problems now? Back in the 90s, wavelets were the answer. So what wavelets actually can do, all right, is take, in this case, a one-dimensional signal and split it up into, this is time, and vertically you're looking at essentially frequencies. So the lower frequencies have been shifted up in this representation, and the higher frequencies have been represented in the lower bands. So I wanted to do that essentially for the textual data that I had. While you were just looking at the continuous wavelet transform, this is a representation of the discrete levels of time resolution captured in a discrete wavelet transform, where you have essentially, what is the if I averaged over the entire thing, what would I see? If I average over the first half and the second half, what would I see? If I would average over, right? And so you can get a sense of, for a shorter and shorter time window that you're looking at the activity, you also have more locations in time at which to look at that, right? And the continuous is essentially taking one of these small things and just moving it just across the scene. So it's a simple idea, but how to translate that idea into text is not trivial. Because unlike in signal processing, we don't have theorems that describe the orthogonality of different frequency components, right? And these different frequency components, they are related, right? They're not strictly separable. The things that are happening, a flash protest, okay, is in fact deeply related to the fact that, you know, the SCAF, Egyptian military generals who were in charge of the country during the transition, that they were not moving fast enough, right? These different levels of activity across different bands are related. Okay, so the next thing I think is important to do is to look back at systems that have, especially textual systems, that have captured at least some of the following things that I would like in a system that we eventually build to solve this problem. So the relationships between documents or frequency bands seems like a really important quality to have. Capturing semantic correlations, you think word to vec, we all know that's valuable, and also to have to capture what is changing over time. I mean that is kind of the underlying goal here. So just to point out some I think important design inspiration. This is, I think this was Washington Post perhaps, where they were trying to show how the same story was being shown with multiple different viewpoints. This is one of my own projects where you could open up a bunch of different books archived by Google to essentially the chapter on the same topic. So you could get different explanations side by side of an underlying idea. It's called Doc Matrix. This is a screenshot from Wickham, which I believe is a project out of MIT, where people tried to group and summarize comments in on a forum, try to show how the comments were related to each other and to some overarching theme. This is a stack skim. This is a project that I think was done for us by a colleague of mine for his class, where he tried to show the relationship between examples posted for a given question on Stack Overflow. This is a really cool one. If you're not familiar with it, it's called Information Cartography by Daphna Shahaf. She graduated from CMU with Carlos Gestrin. She's now a professor in Israel. And what she did was look at the content of articles about, in this case, the Greek financial crisis over time, and try to capture particular articles at these intersections where different, in this case, she wasn't thinking about time resolution, but rather these underlying coherent stories that related to each other over time. And you know, there was a mathematical formulation by which she could pick kind of maximally informative samples from a large corpus to create this, which she called a metromap. Okay. One more example is, this is Wattenberg and Villegas. They created the word trees, if you're not familiar. So this, I think, is a portion of the Bible. And God said a lot of things. And you don't need to read all of those independently. You can kind of get a sense of the distribution over which God said things. Okay. I'm sure many of you are already aware of the semantic correlations that we can capture in neural networks, like cosine similarity and some high-dimensional embedding of words, which we can visualize. But it's, it's capturing semantic relatedness, but it's unclear how to show that change over time. This is another Wattenberg and Villegas project. I think this shows a Wikipedia page being edited by many different people. And so you can see there was an edit war between two people here. But you can't actually see what they were warring about, right? So this captures evolution of a document, a single document over time, but without the content. So it's, again, each of these has qualities that I think are valuable, but don't actually address my original challenge. Oops. You have things like Cosmos viewers that allow you to zoom out. That's kind of also what you want. And then, of course, there's a whole set of design about information visualizations that you can think about, like a theory of how to present this information in a way that people understand. Okay, so with that, I think I have a few moments to show are really, really rough prototypes, and feedback welcome. I mean, gosh, if you can help me, you know, you can, you can be co-author. I don't know. I'm a little stuck. That's why I want to talk to you about this. Hold on. I need to show you. Chrome is hiding. Oh gosh. Sorry. Hi, here we go. Out of visual. Okay. So if you remember the kind of full average, and then the first and the second half, and the quarters and such. Well, what we did was we actually did that process, and we looked at TF-IDF scores, essentially, of the most common terms in each of those time ranges. Okay, so what you see at the lowest level, let's see, this is very hard to. Okay, yeah. So like at the lowest level, we've got things like, and this, I'm sorry that this is a little bit of a bug. I can read off: Mubarak, Muslim Brotherhood, Israel Army, Hosni Mubarak, U.S. Military Brotherhood, Reuters, Cairo. Those are the most popular 10 words across 4 years during the Egyptian Revolution. Okay, that doesn't really tell you a whole lot. But then as we look at higher frequency components, you can see that during this period of time, there was something going on with Coptic Christians, and then Tahrir Square took over as a really common thing. And so you can see Tahrir Square, it shows up in this time scale, and then again in this time scale, and again in this time scale. And so you might be able to start seeing the emergence of higher frequency components as you go up to these more time-limited averaging zones. And the coloring here is based on, I typed in Tahrir, but I could also type in France. And what that shows you is that at the beginning of this data set, there was a big deal going on in Egypt with the France Telecom. So, and then I think France shows up again later because of political situations. So we've played around with trying to make this tell a little bit more of a story. These are articles that were picked out rather than tweets. This was a kind of parallel corpus of news articles, and you can use that previous view to pick out articles, much like in the Metro Maps example. But these still don't necessarily tell a story. And you can, this just gives you a sense of how good projections are. The utility of this is questionable, but you could imagine that, here, when we have gunfire bomb stadium, Rabat, that was a massacre, that if you were able to, essentially brush over a section of related terms here, you could use that as a querying mechanism for any given interface, the previous two that I showed you. So this has been a really fun project, and I hope it inspires you to do something fun this afternoon. If you have any concrete suggestions, please let me know.